Hi everyone, welcome to another Science with Seth video. Today we're going to be looking at paper and how it interacts with fire. In material science, there's something we call the flash point, the point at which an object or material will burn. What we can see is that with paper, it'll burn at a certain temperature, and when you expose paper to fire, it will burn. So when we take water and add it to our paper cup, where at first when it burned without any water in it, when we add the water, it won't burn at all. It'll singe, it'll blacken, but it won't burn. Now, why that happens has to do with a combination of the properties of the paper cup and the properties of the water itself. So when we look at and we study chemicals and materials, we can see that the different chemicals and materials have different properties. For example, because of Ray Bradbury, almost every American school child knows that paper burns at 451 degrees Fahrenheit. What that means is once you get paper to this temperature, it will always catch fire. It'll always kind of start to burn up and then kind of oxidize. We also know that water doesn't really burn. It does two things. It'll either freeze when it gets below 32 degrees Fahrenheit, or water will boil at 212 degrees Fahrenheit. Now, looking at these numbers, we can see that 212 degrees is a lower temperature than 451 degrees Fahrenheit. And when water boils, what's happening is instead of staying in its liquid state, all those molecules start to make their own space and expand and become individual molecules or water vapor. So it becomes a gas instead of a liquid. When we look at our cup that's full of water, what we can see is that our cup in this scenario is very, very thin, meaning the heat can pass through it very, very quickly. So what's happening in our scenario is as we apply heat, as heat gets applied to our cup, it's immediately being transferred to the water, meaning it will only be able to get as hot as that liquid water can get. And because liquid water turns into gas or water vapor at 212 degrees Fahrenheit, the temperature of this water will never reach 451 degrees Fahrenheit. Meaning, every single time any heat is applied, it's going to stay below that ignition point. So what will happen is if we keep applying heat to our cup, that water will start to boil and turn into water vapor. And then of course, it will leave the cup, it'll kind of go into the atmosphere. And eventually our water level will get lower, and then lower, and then lower, until there is no water remaining because it's all been boiled away, it's been boiled off. At that point, there is nothing for this cup to transfer that heat to easily. It can't transfer that heat as easily, and the air itself doesn't conduct heat as well as water does. Meaning, what's going to happen is that paper cup is going to be able to kind of absorb that heat, and it will start to climb until it gets to 451 degrees Fahrenheit. Meaning, eventually, it itself will burn after all that water disappears. Why this is important to an institution that studies paleontology has to do with where we find water. If we look at the planet Earth, we find water everywhere. Most of the surface of our planet is covered with water, most of it's covered with salt water. By understanding the properties that water has, how well it absorbs heat, how well it releases heat, at what point will it turn into a gas, how will it turn into a gas, we can get a better understanding of how that will impact the environment. We can see in coastal areas that have lots and lots of water nearby them, that water is absorbing that heat all through the summertime and is able to release some of that heat in the winter once it gets colder. That's why when we look at the areas around our planet, most of the places that are in coastal environments generally tend to have much more mild summers and mild winters, rather than if you look inland, for example, here in South Dakota, we have very, very hot summers and we have very, very cold winters. So by understanding how water behaves as it's exposed to different materials and different temperatures and things like that, we get a better understanding of how it's going to impact the environment. And of course, since it'll impact the weather will impact the plants will impact the animals, and so on and so forth. And you can see how this whole system fits together. So with that, thank you guys so much for tuning in. If you have any suggestions for an experiment you'd like to see us try, put that in the comments below, and we'll see you next time.